This is example number 1, and it says Athena rubs 2 latex balloons against her hair, causing the balloons to become charged negatively with 2 times 10 to the negative 6 coulombs of charge. What we'll do is let's go ahead and write that on each one of these balloons. So this one is 2 times 10 to the negative 6 coulombs, and this one is also 2 times 10 to the negative 6 coulombs. It says that she holds them a distance of 0.7 meters apart, and they want to know what is the electric force between the two. So we have our distance, and our distance is 0.70 meters between the two balloons. The equation that we'll use for this problem is the force between two charges is equal to K, which is a constant, times Q1 times Q2, all over the distance between them squared. The value for K is pretty large because electricity is a large has a large value, so 9 times 10 to the 9th. And then we can multiply that times 2 times 10 to the negative 6 coulombs for the first balloon. And we can do the same thing for the second balloon, 2 times 10 to the negative 6 coulombs. We can divide that by the distance between them squared, which is 0.70 meters, and we'll square it. Then if you do your math, you should end up with 0.073 newtons as the force between the two balloons. And that should be the end of example number 1. Example number 2, which is the next example here, has to do with puffed rice. So here's a good example of puffed rice, what it looks like. If you ever eat Snap, Crackle, Pop cereal, you'd have the same type of thing. So it's poured into a bowl, and as they're poured out, the two pieces, so let's just say that there's a couple pieces falling in, so we'll just make one piece, and there's another piece, and the force between the two is approximately equal to 4 times 10 to the 23rd newtons. We also know that the distance between the two pieces is 0.03 meters. So we have a force, we have a distance. They want to know what is the charge on each one of the pieces. So in order to find the charge on the pieces, we need to plug everything into our equation. So F is equal to K, Q1, Q2, all over the distance squared. If we plug in our force is 4 times 10 to the negative 23rd newtons. We can also then put in our K value, which is 9 times 10 to the 9th. And at this point, we know that these two should be the same. So the charge on those are the same. So we're just going to say Q squared, and we'll divide it by the distance between them. And we said the distance is 0.03 meters, and we'll square that. If you go through and solve this one, you should end up with Q should be equal to 2 times 10 to the negative 18th coulombs.